Okay, the last thing we're going to do in this chapter is an F-test for a ratio of two variances. So recall that one of our assumptions to the independent sample test for difference in means required equality of variances, and we had our rule of thumb. But what we're going to develop here is just a formal statistical test to check this assumption. That is, the sigma 1 squared equals sigma 2 squared. So when we think about our hypotheses, our null hypothesis is that they would be equal to one another, and our alternative is that they are different from one another. So we'll of course use our sample variances, and let's just first assume s1 squared is bigger than s2 squared. The only reason I say that is because when we form this test statistic, so it's our test statistic, it's going to be what we call an f-stat. We just always put the bigger one in the numerator. So s1 squared over s2 squared. So that's why I'm saying let's just go ahead and say s1 is bigger than s2. But whatever one is bigger goes in the numerator. So f-stat will always be the bigger one divided by the smaller one. So f is a new distribution. It's a continuous distribution depending on two parameters. And so when we're looking at our critical value, it's going to have 2 degrees of freedom. So the first is n1 minus 1, and the second one is n2 minus 1. So it's going to have 2 separate degrees of freedom and alpha, or alpha over 2. So when we think about a rejection region, that's just going to be f-stat bigger than f alpha, or f-stat bigger than f alpha over 2 for a two-sided test. For this, we're pretty much always going to do a two-sided test, so focus on this line. So we will need to look up f alpha over 2, n1 minus 1, and n2 minus 1. So I'm going to show you how to do all of this, but we're just going to use software whenever we're actually doing this in practice. So I'm just going to briefly introduce the F table. So again, you don't have to do this. But we're going to have 2 degrees of freedom. So the first is the numerator degrees of freedom. So you're going to look across these rows, and then you have the denominator degrees of freedom. We're going to look down this column. So just to make this a little more concrete, let's do an example. So we've got two populations with two different sample sizes and standard deviations. So let's answer these 3 questions. So part A. Which sample variance do you place in the numerator? So our answer to A, so because s2 squared is bigger than s1 squared, that means s2 squared goes in the numerator. Right? S2, 25, is bigger than 16, which is why it goes in the numerator. Okay, B, what is the value of f-stat? So B would be f-stat. So bigger one is s2, so we're going to do s2 squared over s1 squared, or 25 over 16, which is 1.562. And then part C, perform a test for equal variances using alpha 0.05. Okay, so let's do this. Start with our hypotheses. So we're just testing for equality, so we'll set these equal to one another for our null hypothesis and say that they're different for the alternative. So this is two-sided. And so our rejection region is just f-stat bigger than f, so n1 minus 1, so both our sample sizes are 25, so n1 minus 1 will be 24, and n2 minus 1 will be 24, so we're going to have 24, 24, and then alpha over 2, because this is two-sided, so 0.025. So this would be f-stat bigger than, so we need to look up this value. So 24. So notice that we have 0.025. There's actually multiple F tables depending on what you want this alpha to be. So 0.025. So we're going to go down to 24. Okay, so go across and then 24. We get 2.27. So this is 2.27. So let's go ahead and plug in our fstat. So fstat is equal to 1.562. And is this bigger than 2.27? No, it's not. So this was F2424.025. So because fstat is not bigger than our F critical value, that means we fail to reject H naught. And so we will assume equal variances. Okay, so ideally, whenever we're doing a two-sample test for difference in means, we would do this first. We would do this F-test to see, okay, can we assume equal variances or not? Rather than just using our rule of thumb, we would do this formal test. Okay, and then we decide, are we going to go ahead and use a pooled variance or a non-pooled variance?